Welcome to Shanti-Peace for Mathematics. The objective of this video is to discuss some examples which is based on a Leibnitz theorem, which is known as a product rule for successive derivatives. So let us write one first example, that is y is equal to sine m into sine inverse of x, then prove that 1 minus x square y n minus 2 n plus 2 is equal to 2n plus 1 x y n plus 1 plus n square minus n square yn. Here we know that this yn represents the nth derivative of y. Y is this function, and yn plus 2 is n plus 2 derivative, yn plus 1 is the n plus 1th derivative, and this is my function is there. So to do this or to solve this example, one should note that it is a n plus 2 derivative, that is the second derivative is there. To discuss the second derivative, so n plus second derivative is there, so it is better that you can calculate what will be the second derivative first, and then you will take the nth derivative of that. That will gives you a formula in terms of yn plus 2. So here a y equal to sine inverse of x is there. Now if I take the derivative both sides, we get y1. So we know that the derivative of sine, it is cos, m sine inverse of x as it is. By chain rule, the derivative of m sine inverse of x is m. The derivative of sine inverse of x, we know it is 1 upon 1 minus x square. So this can be represented by making a square both sides. We will write this as 1 minus x square y1 square equal to m square cos square m sine inverse of x. Why we did this square? Due to the square root. So I want to remove the square root from this, so that's why I will do the square both sides. And then we'll represent this cos square in terms of sine square, because we know the formula is 1 minus sine square will be cos square. So as per that, this is m square 1 minus sine square m into sine inverse of x we can write. And then we'll put the value of sine square, that is y square. So this will give you m square 1 minus y square. So finally what we got is 1 minus x square y1 square is equal to m square 1 minus y square. Differentiating again with respect to x, we get 1 minus x square as it is. So here we have to use the product rule. So 1 minus x square is as it is. The derivative of y1 square, it is 2 into y1 y2. That is, the derivative of y1 square is 2 into y1, and the chain rule, if you apply, the derivative of y1 will be y2. Plus, as per the product rule, y1 square as it is. The derivative of 1 minus x square is minus 2x. The derivative of 1 is 0, x square is minus 2x. Is equal to m square is constant. We will write as it is. A derivative of 1 minus y square, this is 1 minus y square is there. The derivative of 1 is 0, a derivative of y square is 2y, and the derivative of y is y1. So it is 2y y1. You must observe that this y1 is common out from left hand and right hand side, and it will be cancelled. 2y1. So dividing by 2y1 both sides, we get. One more question one can ask is, we can divide any number to anything if it is non-zero. So is the y1 is non-zero here? The answer to this is here in the equation 1, because that y1 square will give you m square 1 minus y square upon 1 minus x square. So y1 is 0 if the 1 minus y square is 0. 1 minus y square is 0, that means y square will be 1. That means y will be plus or minus 1. And what is the function y? Is you have sine of m sine inverse of x, which will never be 1 or minus 1 if your x is in a real number. So we'll divide this 2y1 if the 2y1 is non-zero. Okay, so that will gives me now 1 minus x square y2 minus xy1 is equal to m square y minus. So this is the things we got. Now since this is the y2, and as per the required thing, it is yn plus 2. So if I take the derivative, so taking nth derivative, both sides, we get. So if you want to apply the nth derivative, you have to use the Leibniz rule here, or Leibniz theorem. Let us recall what is the Leibniz theorem first. So the Leibniz theorem says that the u into v nth derivative of that will be u n v plus nc1 u n minus 1 v1. v1 represent the first derivative, u represent and u n minus 1 represent n minus 1 the derivative, plus nc2 u n minus 2 v2, and so on. The last term will be u vn. So here what we have, if I apply the nth derivative to this first term, there will be multiplication of two functions are there. A first one is 1 minus x square, another one is y2. A y2 is also a function of x. So we have to apply this product rule for successive derivative is here. So which value you have to take as u and which one you have to take as v. So you have to take your v value whose derivative after some derivatives will be 0. So I am taking, this is my function v and this one is u. So if I apply this formula, this is un, the first value is un, so that's why it is yn plus 2. Why it is n plus 2? Because the second time derivative is already there and I am doing the nth derivative of this, so it is yn plus second derivative. Then v as it is, so it is 1 minus x square plus nc1. Then as per this, it is un is here, then it is un minus 1. So it is one less derivative of u. U is yn plus 2. So one less derivative of u yn plus 2 is yn plus 1. Then as per this, it is the first derivative of v. The first derivative of v is minus 2x plus nc2. The next term is one less derivative than this. One less derivative than this one is yn. The y2 second step is, or in this term it is y2, v2. A v2 is the second derivative of v, or I can say a derivative of v1. So a derivative of v1 is minus 2. Next, it is NC3, one less derivative of this, that is yn minus 1, and the derivative of minus 2 will be 0. So that is the first things which we have applied a successive derivative to the first term. Now for the second term, in the second term I am taking this is u and this one is, sorry, this will be v and this is my u. So that it is minus of, again I am applying the same thing, but now the role of u and v is changed. V is x, u is y1. So it is the y1 derivative, first derivative is already there, and if I taking the nth derivative of this, it will gives me yn plus 1, x as it is because the function v as it is, plus nc1, one less derivative of yn plus 1, as per this, as I have explained earlier, it is yn. A derivative of x will be gives you 1. In the next term, it is nc2, yn minus 1, that is one less derivative of yn. So it is n minus 1, and the derivative of 1 will be 0. So the next further all the terms in this will be 0. So this is the nth derivative of this term. Now equal to, on the other side it is minus m square is a constant quantity. So it will take out from the derivative, and the derivative of y, you can say it is yn. So finally you will have, this is the expression. Let me simplify this expression and write down. So you will have yn plus 2, 1 minus x square, plus nc1 we can write then n, nc1 is n, and this is minus 2x is there, so I am using that things, that is minus 2x n yn plus 1. In the next term it is nc2, nc2 is n into n minus 1 by 2. So it is n into n minus 1 by 2. So as per that, it is n into n minus 1 by 2 into minus 2 into yn. Plus this term will be 0, so we will not write it. Then it is minus of x yn plus 1. nc1 is n, so it is plus n yn. This term will be 0, so no, we will not write that, and that is equal to minus m square yn. Further you simplify, that means you can collect the coefficient of the yn plus 1. These are the two terms we have. Yn, they are the two terms you have here. So you will have 1 minus x square into yn plus 2 plus the term having the yn plus 1 is this two terms, so that's why the x is also common out, yn plus 1 is also common out. So the quantity left here, it is 2n, and here it is 1, and the sign will become minus 1. So that's why it is minus 2n plus 1 x yn plus 1 plus, here this 2 will get cancelled. So the quantity will come here, it is minus n square plus n square minus n, and the minus is common. If I take minus out, so it will be minus n square minus n upon 2 will get cancelled, so nothing is upon, into yn, and you can just observe that one more yn is there, but it is a plus sign, and I have taken minus common, so it is this will become So let me write down again. So this minus sign, if I take common, then it is n square, because if I take minus common out, n square, then it is plus n minus n yn. On the other side we have minus m square y m square yn. This n is get cancelled. So finally what we get is 1 minus x square yn plus 2 will be, I will take all the things on the other side, because into the what expression I have to prove is this 2n plus 1x yn plus 1 n square minus m square. So we'll have 2n plus 1x yn plus 1 if I take this quantity on the other side, or I will add this quantity both sides. And also here if I add n square yn, then it is plus n square minus m square yn. This will be the final answer you will have. Let's solve one more example. If the cos inverse of y by b is equal to a log of x upon n power n, then prove that x square yn plus 2 plus 2n plus 1 x yn plus 1 plus n square yn equal to 0. Now to solve this one, again the same technique is used as we have did in the previous example. So first of all, what we'll do is we'll just write down what is this expression is y equal to. So for that, what is given is cos inverse of y by b is equal to a log of x by n, power n is there. So that I can write down as n into log of x minus log of n, because we know that log of a power b is b into log of a, and log of a upon b will be log of a minus log of b. So as per this we can write down this is the things, and if I apply cos both sides, then we'll have y by b equal to cos of n into log of x minus log of n. So finally what we have is y will be b into cos of n into log of x minus log of n. Now if we differentiating, both sides with respect to x, we get y1. The b is a constant, so it will stay as it is. A derivative of cos, that we can say it is sine, n log x minus log n is stay as it is. A derivative of this inside term or inside function, the derivative n is a constant quantity and the derivative of log x is 1 upon x. So it will gives me n upon x, and the derivative of log n is 0. N into log n is 0, but I will say log is 0. So it is actually gives me you n by x. The derivative of cos will be minus sign. So finally what we have, it is x into y1 is minus b sine n log x minus log n. We'll do the square both sides. Why we are doing the square? Because I want to put the value of cos. I want cos back here. So we know that the cos square will be 1 minus sine square if I can use, or sine square I can use as 1 minus cos square. So this quantity will become in cos and I can put it the value of y there. So for that I am making a square both sides. So that's for this is x square y1 square will be b square sine square n log x minus log n. That we will write as b square into 1 minus cos square n log x minus n log n. And so 1 minus y cos square, the value of cos square or b into cos, we can say it is y square. So it is b square minus y square we'll have. Oh sorry, I have forgot this n here. So that is n square will be there. So it is n square b square n square y square. So let me write what is the finally we got. It is x square y 1 square is equal to n square b square minus n square y square. This is the quantity. If we differentiating again, with respect to x, why we differentiating? Because the expression which we want to prove, it is containing second derivative, n plus second derivative. So that's why the second derivative is you have to do it. So x square, here we have to use the product rule. X square as it is, derivative of y1 square, it is 2y1 and the derivative of y1 is y2 plus y1 square as it is, derivative of x square is 2x equal to n square b square is a constant quantity, so the derivative of that one is 0, minus n square is a constant, so it stays as it is. The derivative of y square, it is 2y and the derivative of y is y1. Now you just observe that 2y1 is common in all the terms and 2y1 is non-zero. That you can find out from this. The y1 is this and will be non-zero for all those x where the 2y1 is 0. So dividing by 2y1, we get x square y2, because x square 2y1 is got cancelled, plus x y1 equal to n square y. Now applying Leibnitz theorem, or you can just take the nth derivative both sides. What we got is we have to apply the product rule for here, and by taking this is the function u, so this is a function v and this one as u. So as you know that the v as it is, that is x square as it is, nth derivative of y2 it is yn plus 2 plus nc1, a derivative of x square, that is the first derivative, it will be 2x, and the derivative of one less derivative of y n plus 2, it is yn plus 1 plus nc2. The derivative of 2x will be x and the derivative of y n plus 2 less derivative of that, it is yn. The next term, so this is 2 A next derivative of this one is 0. So that's why I will not write that. Into this one, we'll take v here, and for this it is u. So the derivative of here we have to apply the product rule. So for that, we'll say x as it is. So plus x as it is, a derivative of y1, it is yn plus 1. So nth derivative of that, plus nc1. X, a derivative of x is 1, and the derivative of yn plus 1, its this derivative is y, equal to, here it is n square is a constant, a derivative of yn, y, it is y, and the derivative. So we will have this is the things, and if you simplify this quantity, so that will lead to x square yn plus 2 plus n 2x yn plus 1, because nc1 is n, plus n into n minus 1 by 2 into 2yn plus xyn plus 1 plus nyn equal to n square y. You just observe that this 2 will get cancelled out. If you combine the terms of yn plus 1, the terms of yn plus 2 is only 1, so that stays as it is. If you combine this one, you will just see that x is common out, yn plus 1 is also common. So it's left with 2n plus 1 xyn plus 1. Here the quantity is left is n square minus n. This will be plus n yn equal to, on the other side it is y square n. But here I think so this minus sign I forgot. So this minus is here, the minus is also there. Here it is minus. So this n square, n is cancelled out, and so we will have x square n plus 2 plus 2n plus 1 xyn plus 1. This is n square yn, and this minus n square yn will become 2 n square yn equal to 0. Let us discuss one more example of similar type. So if y is equal to sine inverse x whole square, then prove that 1 minus x square yn plus 2 minus 2n plus 1 yn plus 1 minus n square yn equal to 0. So to do this example, we'll proceed as we have did for the other two example in this video. That means here the function y is sine inverse of x whole square. If you take the first derivative of this one, that will give me y1 is 2 sine inverse of x into 1 upon 1 minus x square. So if you take this 1 minus square root of 1 minus x square on the other side, and if you do the square by removing the square root, because I want to take the second derivatives also, so it is better that you can remove this square root from this. So it will give me y1 square 1 minus x square equal to 4 into sine inverse of x whole square. But sine inverse of x whole square is nothing but the y, so that will give me 4y. Now if I take the difference, and I am not writing all the details here, so you just write down the differentiating both sides with respect to x. You will have it is 1 minus x square as it is the derivative of y1, it is 2y1 y2. On the other plus that minus 2x, the derivative of 1 minus x square is minus 2x, and the y1 square as it is. On the other side we have it is 4y, so the derivative is 4y1. and you just observe that this 2y1 is common out, and it will cancel for all those x where this y1 is non-zero. So therefore it will just be 1 minus x square y2, that is left here. Here it is minus x y1. On the other side it will be left with only 2. So this is the equation we have. So applying Leibnitz rule, we get 1 minus x square as it is. The derivative of y2 is yn plus 2. So I am applying the product rule. 1 minus x square as it is, derivative of n, the derivative of y2 will be n plus 2 plus nc1 of first derivative of this quantity, that is 1 minus x square is minus 2x. One base derivative of this, which is yn plus 1 plus nc2. A derivative of minus 2x is minus 2. The one base derivative of this yn plus 1 is yn. So we will left with this, that is the derivative of this first term. Now for the second term, it is minus x as it is, a derivative of y1, and the derivative will be yn plus 1 plus nc1. X, a derivative of x is 1, and the one base derivative of this quantity will be yn, equal to 0 because the derivative of the constant quantity is 0. If you simplify this, then it will be left with 1 minus x square yn plus 2. This is nc1 is n, so it is 2 n x yn plus 1 plus minus 2 will get cancelled. nc2 is n into n minus 1 by 2. 2 will get cancelled out to this and this. So what is left with the minus sign is minus n square minus n. If I take minus common, then we will be this yn. This is minus x yn plus 1 plus n yn equal to 0. And if we further simplify by combining the terms of yn plus 1 and yn, we will achieve our result which we required with this. And then I will let that things is to you complicated. Further, you just add the two terms and simplify the two terms, you will have your answer. Now next problem that we are discussing is to find the nth derivative of y equal to e power m sin inverse of x for x is equal to 0. That means we have to calculate the nth derivative of this quantity at point x is equal to 0. So the question is to calculate the nth derivative of this first, and then we will substitute the value x is equal to 0 there. So for that I will just take the differentiation of this one, that will give me a y1. We know that the derivative of e power x is e power x itself, so e power m sin inverse of x as it is. Then the derivative of this quantity, that is m sin inverse of x, that is m upon square root of 1 minus x square is there. And if I take this square root on the other side and making a square, will leads to the 1 minus x square y1 square is equal to m square e power m sin inverse of x whole square. But this quantity is nothing but the y, so it will give me m square y square. So finally, if I differentiate again with respect to x, will gives me by applying the product rule for the first term, that is 1 minus x square as it is derivative of y1 square, it is 2y1 y2, plus a derivative of 1 minus x square is minus 2x, a derivative of y1 square is already done, so it is y1 square as it is. M square is a constant quantity, so it stays as it is. A derivative of y square, it is 2y y1. And you just observe that 2y1 is common out for all the terms and it's cancelled. So the finally you will left with 1 minus x square y2 minus x y1 is equal to m square y. So we have divided 2y1 and all the terms will get cancelled. Now applying the Leibnitz rule here, or I can say a product rule for successive derivatives. If I apply for the first term, then you will have it as 1 minus x square as it is. A derivative, nth derivative of y2 will be n plus 2 plus nc1. A derivative of this 1 minus x square, it is minus 2x. One less derivative of this one, it is yn plus 1 plus nc2. A less derivative of one more derivative of minus 2x will be minus 2. And the derivative of y, less derivative of yn plus 1 is yn. So you will have, this is the things you can what for the first term. Now for the second term, it is minus x into y1. So x as it is, a derivative of y1, it is yn plus 1 plus nc1. One derivative, first derivative of x is 1. Less derivative of this one, it is yn. The next derivative will become 0, so we will not write that. On the other side, it is m square is a constant quantity. The derivative of y is yn, so it is m square yn. And if you simplify this, what we got, it is 1 minus x square yn plus 2 plus n. So I can say it is minus 2x n yn plus 1, because nc1 is n. This is nc2 and 2 will get cancelled, so it is minus n square minus n yn minus x yn plus 1 minus n into yn equal to m square yn. You just see that this minus minus plus, this yn is get cancelled, yn into yn is get cancelled. So what is the quantity is left is 1 minus x square yn plus 2. And you just combine these two terms, the x is get common out, so it is minus x into yn plus 1 into 2n is left here plus 1. And here this n into yn is got cancelled and you will left with minus n square. And if I take this m square on this side, then it is plus m square yn equal to 0. So this is the quantity is left. Now the question is to calculate the value of this function and the derivative of this function at point x is equal to 0. And we have this expression. So if I substitute x is equal to 0 here, so putting x is equal to 0 will gives me very nice equation, that is a recurrence relation I can say. So we'll have the x is equal to 0, you have to substitute, so it is yn plus 2 at 0. Here you will have x is 0, so this term will goes to 0. And here you will have n square plus m square yn at 0. And because of it is minus n, I will take on the other side. So it is m square minus m square yn at 0. And this expression is true for all the values which we have for n equal to 0, 1, 2 up to so on. And since this will start with y2, so we have to calculate what is y1, what is y at 0. So for that, I may call this is equation 1. This is the equation 2 which we have calculated, and this one is equation 3. So if I put x is equal to 0 in equation 1, x is equal to 0, putting x is equal to 0, in 1, 2 and 3, we get y at 0 for the first two. By putting 1, y at 0. The y at 0 we have, it is, if I substitute 0 here, it is e power 0. E power 0 is 1, so it is y at 0 is 1. y1 at 0, that you can see, if I put x is equal to 0 here in this expression, this is 0, that is y1 square at 0, and m square, here on this side it is m square, y square at 0, but y is 0, so it is y1 square is equal to m square. So what we'll have is y1 is m. y2 at 0, again by putting x is equal to 0, this term will become 0. This is y at 0. Y at 0 is 1, as we know, so it is on this side is m square, and here it is y2, so it is m square. So we have it as m square. Now this expression is true for 0, 1, 2, 3. So if I put 0 here, it will give me y2. y2 already I have calculated. Now we'll have to calculate what is y3. So I'm putting the, if I can call this is equation number 4, and if I put n equal to 1 in 4, putting n equal to 1 in 4, we'll have y3 at 0. So what is y3 at 0? It is 1 square plus m square. So this is m square plus m square. So plus m square, 1 square plus m square into y1 at 0. But y1 at 1, you have the answer is m 1 square plus m square. If I put n equal to 2 in 4, then that will leads to 4y4 at 0. And you just observe that it is 2 square plus m square, y2 at 0. So it will gives me 2 square plus m square, y2 at 0. But y2 at 0, as per this, it is m square. So it is gives me m square, 2 square plus m square. And if you go further, that means if I put n equal to 3 in 4, then we'll have y5 at 0. y5 at 0 will gives me 3 square plus m square, y3 at 0. But y3 is this, so it will gives me m 1 square plus m square plus 3 square plus m square. If I put n equal to 4 in 4, then that will gives me y6 at 0. And by some calculation, you can just observe that the y6 is m square, 1 square plus m square plus 4 square plus m square. And this leads to a conclusion that if n is even, then it has value is different, and n is odd, then it has a value different. So what will be the yn at 0 in general? You can write yn at 0, it has even, n is even. If n is even, If n is even, then you can just see that it is m square, 1 square, m square, 4 square, m square, plus so and so on. So it is m square. Sorry, this is not 2 square, but it is not 1 square, but it is 2 square. So it is 2 square, m square, up to so on. So when it is a 6, it will reach to 4. When it is 4, it will reach to 2. So in particular, it is n minus 2 square plus m square. If n is odd, then it will start with m. 1 square plus m square. Then it is 3 square plus m square and goes to. When it is 5, it will reach to 3. When it is 3, it will reach to 1. So it is n minus 2 square plus m square. So this is the value of yn at 0. I am giving you one exercise for you to do it. So question is y equal to sine m sine inverse of x. Then find yn at 0. That's it for this video. If you like this video, please press the like button. If you have any comment, suggestion or question, please drop down in the comment box below. See you in next video. Till then, bye bye. Sayonara.